Hi, welcome to VR Interphysics channel. If you like the video, like it, share it and subscribe my channel for upcoming videos. Today we are going to discussing the topic formation of stationary waves in an open pipe and deriving the equations for the frequencies. Hi, in our previous session we discussed about the formation of stationary waves in stretched string. And we discussed one more also, laws of Troser waves in stretched string. So today we are going to discussing the topic formation of stationary waves in open pipe and derivation of frequencies. So here organ pipes are two types. One is the open pipe, second one is the closed pipe. So here when a sound wave travelled through the pipe, so then what happens? When one incident ray passes through the pipe and when it touches the ends or when it reaches the end point and it comes to the reflected. So when the wave will be reflected by the superimposition of one incident ray, one reflected ray, the stationary waves will be formed. So here today we are observing the formation of stationary waves in open pipe. First of all, what is the difference between the open pipe and the closed pipe? So open pipe means if a organ pipe opened at both end sides, that is called as a open pipe. And next, what is the closed pipe? Closed pipe means if one end is closed for a organ pipe, that pipe is called as a closed pipe. Later we discussed about the closed pipe. So first of all, open pipe. Open pipe means what is that one? If both ends are opened, that pipe is called as a open pipe. So here what happens, when sound wave travels through the one point, it will be moves in the pipe, and when it goes to the back reflected, it will be forms the stationary waves. And here you have to observe 2 points are there in the stationary waves. One is the node, second one is the antinode. So what is the meaning of node? Already we discussed it. Node means if displacement is 0, that is the node. Antinode means if displacement is maximum, that is called antinode. So here observe, at the both ends are opened. So there is a choice is there to move particulars at a maximum displacement. So always at the open sides, antinode will be formed. Why? Because reason is there. What is the reason? Here at the both ends, the medium of the particles will be moves at high. So amplitude is high. So it means the displacement is maximum. So antinode will be formed. So at the always open side, antinode will be formed. So here observe, I am drawing the antinode. And here one loop is there. So this type of is called as a first harmonic. So in the first harmonic, how many loops will be formed? Means one loop. In the second harmonic, how many loops will be formed? 2. In the third harmonic, how many loops will be formed? 3. So like this, here in the every harmonic, the number is belongs to that name only. First harmonic, 1 loop. Second harmonic, 2 loops. In the third harmonic, 3 loops. Like this. So here now, we have to derive the frequency equations for these harmonics. So first of all, assume here I am taking the length of the pipe is L, and here once observe, this is the antinode and this is also second antinode. The distance between the two antinodes is equal to the lambda by 2. So here it is equal to the lambda by 2. So it means I don't know the length of the pipe, that's why I am taking the L. And by the wavelength definition, it came as a lambda by 2. So it means L is equal to the lambda by 2 from the figure. So first of all, already we know the velocity of the sound equation, V is equal to mu into lambda. So for the first frequency, it is V is equal to mu into lambda. So what is the meaning here? V means velocity of sound, nu means frequency, and lambda is wavelength. So here first of all I am finding the frequency value for the first harmonic. So that's why I am writing to indicate first I am writing the nu 1 lambda 1. So what we have to find one frequency. So nu 1. So here what happens, nu 1 is equals V by lambda 1. But here once observe, L is called lambda by 2. So here also you have to write the lambda 1. Why? Because first harmonic wavelength. So then what happens, this is the first equation. From the figure, L is equals lambda 1 by 2. So it means lambda 1 is equals 2 into L. So L is called lambda 1 by 2. This 2 comes to the left side. Lambda 1 is called 2L. So now I got the lambda 1 value. Substitute the lambda 1 in the first equation. Then what happens? Nu 1 is equals V by 2L. So this is the first fundamental frequency. So this is the first harmonic frequency. The other name is called as a fundamental frequency also. And next, second harmonic. Here observe, what is the condition in the second harmonic? 2 loops will be forms. That is the one condition. Second one, at the open ends it will be forms antinodes. So here I am taking open pipe like this. Always here forms it will be only. And in the middle what happens? One loop will be forms. So here once observe one loop and these are the one loop. 2 loops are there. So this is the second harmonic. As usual, the length of the pipe I am taking as a L. And here observe, this is the one antinode. And this is the second antinode. And this is the third antinode. So here, this distance between 2 antinodes is equal to lambda 2 by 2. And here also, lambda 2 by 2. So then, what is the total distance between comes to this one? 2 lambda 2 by 2. Why? Because we have to add this 2. So it is equal to the L. So now L is in the second harmonic. L is equal to the 2 lambda 2 by 2. So now this what we will get? Lambda 2 is equal to 2 into L by 2. So for here, second one, V is equal to nu 2 lambda 2. Why I am writing the second? This is the second harmonic. That's why I am writing nu 2 lambda 2. Then what happens? Nu 2 is equal to V by lambda 2. But here lambda 2 is equal to the 2L by 2. So write like this only. 2L by 2. When this 2 comes to the upper side, 2 into V by 2L. But here V by 2L is equal to the nu 1 from the second equation. So it is equal to the 2 into nu 1. So it means nu 2 it is equal to the 2 into nu 1. So this is the third equation. So it is the fundamental frequency and it is the second frequency. And next we are going to discussing about the third harmonic frequency. So third harmonic means as usual 3 loops will be formed and second condition is at the open side it will be forms antinode always. So here in the middle how many loops will be there? 2 loops. So 1, 2, 3. So here as usual the length of the pipe I am taking as a L only. Why? Because always the length of the pipe will be not changes. And here 1, 2, 3, 4. 4 antinodes are there. I am taking lambda 3. Why? Because this is the third harmonic. Lambda 3 by 2 at the first 2 antinode distance and at the second, third antinode distance lambda 3 by 2 and here also lambda 3 by 2. When you are adding all these, then you will be get the 3 lambda 3 by 2. It is equal to the L. So from this equation, what we will get? Lambda 3 is equal to 2L by 3. Now observe here third frequency V is equal to nu 3 into lambda 3. So here then what happens? Nu 3 is equal to V by lambda 3. But lambda 3 is we will get 2L by 3. So here lambda 3 is equal to 2L by 3. So nu3 is equal to V by lambda 3. But here lambda 3 is equal to 2L by 3. Substituting this value in this equation, what we will get? V by 2L by 3. When 3 comes to the upside, 3 into V by 2L. But here V by 2L is equal to the nu1. So it is equal to the nu3 is equal to the 3 into nu1. So this is the fourth equation. So from the second, third, fourth equations, what we will get? V by 2L, 2V by 2L, 3V by 2L, like this. So here the ratio of the three frequencies is equal to the 1:2:3:, like that. So here the ratio nu1:, nu2:, nu3, so on. It is comes as a 1:2:3:, like this. So these are the frequencies of stationary waves in the open pipe. So fundamental frequency nu1 is called V by 2L, and second frequency 2 into V by 2L, and third frequency 3 into V by 2L. Fourth frequency we will get the 4 into V by 2L. So when we want to get the 50 frequency, then 50 into V by 2L. So like this, these are about the formation of stationary waves in the open pipes. In the latter, we discussed about the formation of stationary waves in the closed pipe. Thank you.
Thank you for watching my video.